Have you ever caught anything on fire while you're welding?
Oh, yeah.
Here today we have our welding expert, Terry Bennett. Terry's been with us for many years, welding a lot of our products. If you guys have bought any of our products that have welds on it, more than likely Terry's done those. And today we brought him here to teach you guys a little bit about welding.
My name's Terry Bennett, as he said. I've been welding in the aircraft business for over 40 years. I've been welding now professionally for over 50. I've done ICT's work since pretty much their inception. My specialty is aluminum, but in the aircraft business I did Inconel titanium, magnesium, steel, and many, many other metals that you ain't heard of.
How did you guys go about welding those type of structural items, and are they tested, and what certifications and things do you have to do that kind of work?
Yeah, there's a lot of extreme certifications and inspections, X-ray, most all parts on all military and Air Force One and the NASA stuff was all pretty much, it's all X-rayed. That's all there is to it. It's all X-rayed, it's penetrant inspected, and it goes through many inspections.
And do you have to have certifications just to work on those things? To be able to weld?
You have to have a certification in every material you work in and different sizes. So at one time, I carried over 15 weld certifications alone.
Wow. So different sizes, like thicknesses?
Different thicknesses, different alloys, different, some of them crossed over, so like some of the stainlesses, there's so many different kinds of stainlesses. Some, everybody thinks is all magnetic or non-magnetic, but there are, 410 is magnetic. But most, a lot of different stainlesses, Inconel covered like Hastelloy and other materials, but yeah, there's several different kinds of Inconel too.
Is there different grades or tiers of welders, and how does that work?
Welded for Cessna for 10 years and Boeing for over 30. Yes and no, you get graded as you go higher, but you also get graded by what you're welding on. You can tell where you're at by what you're working on.
So the higher up, the more experience you have, the higher grade of part or repair or something you would get?
Yeah, well, I was the flight line welder for about 15 years of my 30 plus at Boeing. You don't go over there unless you're really good. Let's just put it that way.
On those type of things, what's the most critical thing you've welded?
Back in the Cessna days, I welded the gear strut and wing spar, all one unit, for the ag wagon, which is pretty important to keeping the wings and the landing gear on.
Sounds like you might need those.
On the other planes, we did all the engine ducts and everything for anything from Air Force One to tankers and basically everything, 737s, 747s, 757, 777, 787, you name it.
So when you're welding, what makes a bad weld?
Well, a bad weld can be caused by a lot of things. Porosity for one, but the sand castings that we do for the timing covers, they are porosity to start with, so that's always fun because they like to blow up in your face a little bit.
So kind of explain to people that don't know about welding, what that even means and what you're seeing when you're welding and why that's tough.
Okay, the majority of parts you guys build is done with billet material. That's where the name comes from. It's, good manufactured material. What the sand casting is poured aluminum into a mold, a sand casting mold, which has built-in porosity to start with. Still a good part. It does have little tiny holes, which you don't want in a weld, and you pick those up when you weld.
It's you get oil on things in those cast materials.
Right, it's like a big sponge. It's that's the problem. It picks up stuff, or silica. The silica from the sand will be in there too, to a small degree. It doesn't make it a bad weld, it just sometimes is not as, well, a lot of times it's not near as pretty as it's going to be on nice material.
So for the guys in the garage that are just starting to learn this, try to figure it out, what things should they look out for that would, make them have a good weld instead of them welding it and it fails or breaks off or something?
Cold lap and undercut are two major things.
What's a cold lap?
A cold lap means you've got lap material too much and it's got an edge that's got a line under it. It's a nice place to start a crack. Undercut, same thing. You don't have enough fill, you've got a good way to start a crack because it's not filling up to the full extent of the material you're welding.
Is that where you would take like the material down between the two so you have more room to like fill it back in?
Well, no, that'd basically be a way to get more penetration, would be why you would groove it or something beforehand. And that's good too, depending on what you're wanting to do. You can
Just
weld
for thicker
If
material.
you can't weld from both sides, that's going to be a good option. If you're a TIG welder, you're going to want on any ferrous material, you're going to want a backing gas as well.
What's a ferrous material for the people that don't know?
Okay, it's going to be your steels, your stainless, your Inconels, your titaniums. The only non-ferrous that I ever weld for the most part is magnesium and aluminum.
Is there certain types of material that you would just use a MIG for, or?
In the business I was in, MIG was unacceptable. I use a lot of MIG in my shop for some things. When it's critical, I still like TIG. If I want it pretty, I still like TIG. The MIG weld, I don't mean to say this in a bad way to anybody out there, but anybody can do it. If you want to learn to MIG weld, you can learn. But it's pretty simple to learn how to MIG weld. TIG weld is a whole different monkey. With the wire feed, you're pretty much set a speed and you can control it by how close and how far apart you are from your material. With TIG, you've got a foot pedal that controls your heat. And it's like driving a car. The more heat you want, the more gas you give it, It's just an up and down pedal and you can manipulate everything you're doing. That's how you get the pretty ripples. And if you have an arrowhead looking weld, then you're welding too fast and too hot.
What all parts have you made for us?
Wow, in the beginning we started out with turbo tubes, which we don't even do anymore.
Oh, I don't even remember those.
Yeah, that's when it's still working out of a garage, I think.
And the plate and the tube welded onto it.
Yeah, and then we did motorcycle oil pickups. We did several different styles of those for some Suzukis, I believe. From there we got into the timing covers, and that has been a big boom for myself and you guys, I believe, as well. And we've gone through good castings, bad castings, so we really know what we've got now, and it's really nice. And then we got into the engine lifts, and the engine lifts were a lot trickier again. New material, which was fantastic, but we also ran into the problem of having not enough heat, so we're mixing gases with, I'm running about 50-50 helium and argon. You can run, still staying on the AC level of your TIG machine, you can run more heat if you mix your gases. It takes some Y valves or stuff to do it. It takes a little ingenuity to figure out how to mix your gases. But you need 2 bottles, you need 2 regulators, and you need a Y deal where you can sort them to get the bubbles where you want them. Helium can be welded on DC also with aluminum. If you know what you're doing, you can run straight DC like you'd be doing a steel weld. You can't do that with AC. You cannot do that at all with aluminum.
And is that what you used like in previous times, doing like heavy duty, like aluminum?
Yes, I've done that for tooling. When I'd get loaned into tooling at my previous jobs, I would use a lot of helium. We would run straight helium on a lot of jobs for tools that held things 20, 30 foot in the air. Yes, we did a lot of that. Air Force One had a lot of that for roll-up tools to the plane and stuff, as well. It's a faster weld if you know what you're doing, but it's not as pretty.
Do you ever preheat the materials?
On magnesium, we used to always preheat.
Why is that?
Because it'll crack if you don't, when it cools off too fast. Just kind of, if you've ever welded cast iron, you have to almost always preheat that and post-heat it, because if it cools down too fast, you'll hear it tink, and everything you did is for naught.
On the post-heating, so you're done welding, and then you just kind of like gradually bring it down, you just put a little bit of heat on it. And then
well, a lot of people, what they do, and I've done this myself, if you don't have an oven, when I worked for aircraft businesses, we had ovens, but if you don't have an oven, I'll bet you got a backyard charcoal, or not a charcoal, but a gas grill, they work really good.
So you just like work it down over like an hour or something?
Yeah,
or how?
yeah, let it cool down slowly, get your heat up. When it's hot, get on it welding, get it real hot, and heat it up slowly as well, but get it heated up, and then you weld it, and then you get it back in there as hot as you can keep it, and then you let it keep the temperature on it and cool it down over time. 400, and I know that your weld's going to be way hotter than that, but that's about as best you're going to get out of a cooker. It will still, you're losing heat. The weld itself is much hotter than that, but the material around it doesn't stay that hot. So
if you were a rookie welder, just starting off, don't know what you're doing, don't have a welder yet, what would you recommend for them? Just somebody that's like maybe a car builder, somebody in their garage that just wants to get started with something.
I think I would start with MIG, even though, well, I'll tell you what, any little class you could take from any vocational area around you is not a waste of time or money. Everybody wants to move straight to TIG. It's a better weld in a roundabout way. It depends. It depends on how thick a material and whatever, but your thinner materials are going to be easier to weld with TIG because you've got more control over your heat.
So on those, do you think somebody would buy like a TIG, like if they're wanting to do aluminum, like piping and things on there, then they'd have to get a TIG, wouldn't they?
Yeah, if you're going to weld TIG or aluminum, you're going to have a TIG. That's the bottom line. I mean, there's wire feeds that can do it, but I don't trust them, but that's me.
Have you ever seen anybody with like a cheap welder that actually worked well? Or do you think like somebody should just start off with like a really good one?
Wow, what a question. I'm a true blue guy. If you're a welder, you know what I mean. I'm a Miller guy from start to finish. Lincoln builds a good product too. There's other people out there now that are competing, and I understand they're building a good product. You know what you learn what you want to work on, work with, what tools you want. You know, if you're a Craftsman guy or a Snap-on guy, you know what you want to work with. That's kind of the difference. I put Miller at the top. Some other people would argue with me. They could be wrong.
So if somebody's just starting off, what type of equipment do you think they should buy with it? You know, like gloves, helmet, like do you have any recommendations that you think?
You're going to need good gloves. If you're welding wire feed, you're probably going to want to get the heavier type of gloves. If you're going to be TIG welding, they make some real nice TIG gloves. They're going to cost you 20 to 30 bucks a pair, but they're a thin leather, and they're going to get hot quicker, but they're going to still protect you for the most part. As for a welding hood, man, I mean, I get an automatic. They're good these days. They didn't used to be. They're great now. That's the nice thing about these new ones now. You can change your shades, you can change intensity, you can change a lot of different things on them. And if you're welding something like an Inconel, in the aircraft business, it's extremely cloudy and hard to see. You're running an 8 or a 9. You know, and a stick welder, you're going to be running those too, because if you're stick welding, those are going to be your brighter arcs. You know, you're going to get flashed sometime with your arc, and when you do, it hurts.
You ever have to hold a potato to your eye?
Oh, yes.
Is that actually a real thing?
It's a real thing. Whether it really works or not, it still hurts like hell for quite a while, like a day or two at least. Yeah, I mean, you want to protect what's around you. You want to make sure you don't start fires. You don't want to be around anything flammable. If you can help it, you definitely need to protect yourself. You know, whether it's a blanket, whether it's a leather apron, or, you know, if you're an arc welder or a wire feeder, you're probably wearing leather arms, you know, and stuff too, you know. So there's those things to look at. There's a multitude of ways to protect yourself, and blankets are good if you're going to be covering something to keep from burning. You're going to need protection for your arms, your chest, you know, those things. That is radiation. You know, you are putting yourself in harm's way.
Have you ever caught anything on fire while you're welding?
Oh yeah.
Maybe any tips to anybody out there?
Well, I mean, for the most part, the only times I've really caught anything on fire was a little magnesium fire, which there's no such thing as a little magnesium fire.
So that's something where, like, you can't put water on it.
No. It just intensifies.
What's your brand name?
Well, my business name is T&M Welding, and you will not find it in the phone book. You're going to have to find it through somebody that knows how to get a hold of me, because it's not something, I'm not looking for walk-in traffic, I'm looking for contract parts.
Appreciate you coming here today and talking to us and telling everybody a bit about some of the welding stuff and some of your experiences. Definitely super experienced, and we love having you do our parts, and that's why our parts are so great, and they just stay together and won't fall apart.
I appreciate it very much, Alan, and I enjoy working for you guys.